All right. So we start with the basic stuff. Start with the basic stuff. Solid, liquid, gas. Okay. So we start with the basic stuff, which is solid, liquid, and gas. I'm sure you have learned this before. Okay, I'm sure you have learned this before. Solid, liquid, gas, okay, the arrangement of particles. So you have learned arrangement of particles. This is the first thing you learn when you are in year 7. Okay, what is solid, what is liquid, what is gas. And then the first thing you have learned is also particles. Correct. Okay, so particles like in solid, oh, they're all together like this. Okay, I'm sure you know. And then liquid. Okay, so one mistake that a lot of students make is liquid is like this, and then gas is like this. Okay, it's not like that. Okay, liquid is also touchy. Have you ever gone for swimming and then you see there's a hole inside the water? Of course not. Okay, so liquid particles are also touching each other. It's just that they are not in a arrangement, a sequence arrangement. Now, there are three types of particles. The three types of particles are atoms, molecules, and ions. Okay, three types of particles. So in a solid, in a liquid, in a gas, they can either be atoms, liquids, or gases. Okay. Now, what happens is if it is a solid, what happens is all the particles are in a fixed position. Okay, they cannot move around. So we just say they vibrate in a fixed position. Or what happens is because they are arranged in a specific structure, we call this arrangement a lattice arrangement, or it's also known as a regular arrangement. Okay, it's a lattice arrangement or a regular arrangement. Now, the particles are all touching each other, okay, and this is called solid. Now, liquid, what happens is, if you ever gone swimming before, you slide your fingers through, right? So, in a liquid, the particles slide over each other, but their arrangement is just random. Okay, for gas, you're going to have your favorite word. It's just the arrangement is random and the movement is random. And they're all far away from each other. They're not touching. So this is the basic where we talk about solid, liquid, gas. Okay. Now, the second basic stuff that we talk about is heating and cooling. Okay, so I'm sure you know this. If something is a solid become liquid, it's melting. Liquid become solid, it's called freezing. Okay, liquid become gas is evaporation or boiling. Gas become liquid is condensation. Okay, okay. Now, if a solid directly becomes gas, do you know what it's called? Sublimation. Sublimation. Okay, so this is called sublimation. A solid directly becomes the gas, it's called sublimation. Okay, now, do you uh have you seen this before? Since what? Okay. So the first chapter of year 10 is just going through all the basics that you learn in year 7 and 8 and 9. And now, the most important thing that we learn in this subchapter is heating curve and cooling curve. Okay, so for example, if I have substance X and I heat it up, okay, heating curve will always be like this. As long as it's a pure substance will always have a very specific melting point and boiling point. If it's an impure substance, then the melting point will be lower and the boiling point will be higher. Okay, so you heat up something. Okay, you've seen this before, right? Heating curve. Okay, so this part is always, so S is for solid, L is for liquid, and G is for gas. Okay, so this one is solid only. This is a mixture of solid and liquid. This is liquid only. This is liquid and gas, and this is gas only. Okay, this temperature where it boils is called the boiling point, and this temperature where it melts is called the melting point. Okay, very quickly, can you just draw this in your notebook or in somewhere on your paper? Okay, because I'm just going to talk a little bit of this, and then we're going to do some machines. Yes, turn it on. Yay! I think you have to turn on the main one. Mm. Huh? All right. So now what happens is we already know here's the melting point and here is the boiling point. Okay, this question of this particular subtopic, the only hard thing they will ask you is what is the melting point? What is the boiling point? Okay, and then they will ask you things like what is the state of matter? So the state of matter also you got three states lah, solid, liquid, gas. Okay, so then if it's here, you must specifically say mixture of solid and liquid. Here you have to specifically say mixture of liquid and gas. Okay, now all of these are physical changes. Why are they physical changes? Because it's still particle X. It's still X. It doesn't change into XY. It's still the same thing. There's no chemical changes occurring. It still maintains the same. Now, another thing that they will ask you is, okay, so please write down this question. Okay, so write an equation at the melting point. MT is the melting point, okay? Okay, write an equation in the melting point. What does that mean? All right. So, like this, okay? At melting point, it's solid, but it's a mixture of solid and liquid. So what happens is all the solid and liquid won't turn into only solid until it is fully melted. Okay, so what happens here is mixture of solid and liquid, right? So X, let's say this is substance X, is in the form of solid. S means solid. It becomes a liquid. It becomes a liquid X. But at the same time, some of the liquid X changes back to become solid. This kind of equation is called a reversible equation. This is the only so-called hard question that they will ask in this subtopic. What is the equilibrium reaction, or what is the reaction at the melting point? So this is changing back and forth, changing back and forth. Why is it changing back and forth? Because the energy is used to break all the bonds. So it will only change to fully liquid when all the bonds are broken. Can? Okay, that is chapter 1. Finish reading. It's very, very simple. Okay, what I want you all to do is, can you see the questions? Okay, I want you to take just 5 minutes, quickly do the questions. It shouldn't take you long. They're very, very simple questions. Just take 5 minutes, do the questions on this paper. Okay, because I want to quickly go to the next chapter. I no need to do all, just do the first. Is this what you had? I think I opened the wrong one. Yeah. Okay. Right. Do the first 2 pages. Yeah, just do the first 2 pages. Okay. Oh my goodness, you look exactly like your brother. You look exactly like your brother. What's your name? Eugene. You're Isam's brother. Okay. Seriously, look exactly the same. Yeah. Come. Um, you were late. So, for your information, in this class, everyone sits in front. You can sit here, you can sit there, whichever one. Hey guys, is there an actual Ariel in the class now? Does she come for class? Is it a girl or a boy? It's a guy. Does he come for class? He's always late. And then Jia Yi, I know. Then is there a Xuan Yi also? There's an actual person, Xuan Yi. All right. But he's also always late. Well, not always. Not always. Does he come for chemistry? Do you know? Oh, then maybe he doesn't take chemistry then. Okay. EG. All right. A? A? I gave you the wrong paper. OMG. I gave you the wrong paper. No. What's total? Ah, correct, correct. I am opening the wrong picture. Anyway, I'm recording this lesson for Chai, so you can. So how many of you in the class are from Catholic High School? You, Chai, some more? Sorry, what's the name? Xuan and Ariel, four of you lah. And Chai lah, correct lah? Okay. Alright, come, let's discuss. Okay, so, dun, 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 dun. Okay, if you don't know how to answer this, okay, we all sit down and cry, ah. Okay, so A is boiling, B is freezing, and then C is condensation. Okay, so this is like Science 101. If you don't know this, really, we sit down and cry. Okay, remember our timeline. Okay, so Ejin, you weren't here just now. We were talking about timeline. 2026 until October, we're gonna do half of the syllabus. And then 2027 from January until October, we're gonna some maybe October, November. I see when you guys have holidays. Then we will do your IG cam already. Okay, that's our timeline. Our timeline is like this. So you have to prepare. Okay? All right. Now, solid is yeah, lattice or regular. No. This is particle separation. Sorry. Touching. Yes, you're right. Touching. Okay. So particle arrangement is regular. So regular this one is random also. Okay, and then gas is also random. So your favorite word is actually random. Okay, it's random, moving randomly. Okay. All right, this one. When nitrogen dioxide is cooled, it forms a yellow liquid and then pale yellow crystals. These crystals are heated and the temperature is measured every minute following the graph. Okay, describe the arrangement and movement of the molecules in region AB. So you need to know lah from just now, AB is a solid. Do you guys have the same paper? Because sometimes I have too many versions. Same paper, Okay. So the arrangement and the movement. So arrangement is regular arrangement and the movement is vibrate at fixed position. So I have 7 boys in this class. Okay, that's interesting. Okay. So this one is called a heating curve. This one is called a cooling curve. It's just the other way around. Okay. So what happens is a sample of gas is cool. Okay. So AB is called no, this would be freezing, because this would be solid. Condensation. Okay. All right. The next thing we're going to learn about is called diffusion. Okay. Diffusion is the movement of particles from high concentration to low concentration. Yeah. No, not yet, because I want to teach you this one first. Okay, so diffusion is the movement of particles from high concentration to low concentration. What is it? Okay. Okay. What did you come from? Where did you come from? Like you came from home or you came from sports? Oh, so you just woke up late. Okay. Can you wake up earlier next time? We are on a very short timeline. Okay. All right. So particles move, gas particles move from high concentration like this, it will diffuse to low concentration. Okay. Why do they diffuse? Because the particles are always moving randomly, they have kinetic energy. The higher the temperature, the more kinetic energy they have, the faster they diffuse. What causes something to diffuse faster or slower? Okay, so what causes them to diffuse faster or slower? It is the mass of the molecule. So if you look at this, a student set up apparatus, and here they have hydrochloric acid, concentrated hydrochloric acid. So it gives out hydrogen chloride gas. Hydrogen chloride gas, the formula is HCl. It is an acidic gas when it dissolves in water. So this hydrogen chloride gas will start to diffuse. At the start, they're all here. After a while, they are here. Some are here. And then after a while, it will all be here. So the reason why it's red is because acid turns litmus paper red. Okay, so how do you answer? So the first thing that happens is from the liquid, evaporation starts. So evaporation of hydrogen chloride. First, it must evaporate because even over here is a liquid first. And then after that, the particles will move away by diffusion and they will collide one another and they will randomly move. They will randomly move. And when they hit the litmus paper, the hydrochloric acid particles will move from high to low concentration. They cause the litmus paper to turn red. So that's what diffusion means. Okay, so a bottle of liquid perfume is left open. After some time, the perfume is smelled at the back of the room. Two physical processes that take place: diffusion and evaporation. Okay, can? Okay, so these are all, this is just recap things that you've learned before. So I don't have to really, really like go very detailed. Oh, oops, sorry. Can I? All right. Now, ammonia is NH3. Hydrochloric acid is HCl. Every single element is given a mass number in the periodic table. Okay, so I'm going to tell you now, nitrogen is 14, hydrogen is 1. Okay, in that case, if nitrogen is 14, hydrogen is 1, that's called the relative mass of something. What is the relative mass of ammonia? Can you tell me? 70. So nitrogen is 14, hydrogen is 1 times 3, so you get 17. Okay, so that means if nitrogen was a big guy, nitrogen will be 17 kg. Or it'd be a small child, 17 kg. But what about HCl? Hydrogen is 1, chlorine is 35.5. Okay, so then chlorine, HCl, will be 36.5. Okay, so who's a bigger guy? HCl or NH3? And HCl is a bigger guy. So HCl will move faster or slower? Slower. So what happens is when you put ammonia on this side, ammonia will start to diffuse. Da, 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 da. Then hydrochloric acid will also start to diffuse as HCl gas, hydrogen chloride gas. But because it's a bigger guy, it go do, 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 do. So by the time they meet together, they will meet nearer to HCl. Why is there a white film? Because these two molecules, HCl and ammonium chloride, when they see each other, they love each other so much, they form ammonium chloride, and this forms a white film. Okay, this forms a white film. Okay, can you try and do this question? It's just 1, 2, 3. Okay, try and do this question. No, after this comes on your what? Econs. Is it? Then after that, break, and then physics. No, bio. Today, how many classes for? What's the last one? Uh, oh, AdMaths is on AdMaths is on weekday. Friday AdMaths. All right. Okay. Random movement of particles, diffusion lah, ada. Okay. White solid, this one the name, Remember I told you the formula? The name is very specific. I will teach you how to name stuff later. You want to do any spelling mistake in chemistry, don't name the molecule formula wrong because you cannot say spelling mistake. Ammonium chloride. Ammonium chloride. You want to spell water wrong, go ahead. You want to spell beaker wrong, go ahead. You want to spell formulas wrong, cannot. Because the marks are in the spelling for this one. Okay? Other stuff, you want to spell your name wrong, also go ahead. All right? Why the white solid is formed? Okay, this one is a 3-mark question. IG is very mark oriented. So always look at the marks. Okay, so you must explain a little bit. The relative mass of ammonia, NH3. Okay, I cannot write like this. Do you get confused? Okay, the relative mass of ammonia is 17. HCl is 36.5. So Cl has a higher relative molecular mass. Okay, the term is relative. The term is relative molecular mass. So HCl diffuses slower. Okay, can?
So that's 3 marks.
Yeah, that's true. Please.
Ask the math and I'm questions.
1-1, all 1-1. If I don't write, it's all 1-1. You have arrived, and your name is Jared. Oh, orchestra.
Yeah.
Come. In this class, everybody has to sit in front. No, supposed to sound Ariel. Right.
What is it?
Chemistry.
Teacher.
You are late. 1. Number 2, I recorded the first part of the tape, so you have to go and watch it yourself, okay? Can? Okay, ready? Can I go on? Can I? Okay. Yeah, okay, so a student placed some crystals of salt, so salt crystals at the bottom of a beaker. She left the content for 1 hour, the diagram actually. So after 15 minutes, half of it. So let's say this is a pink substance. So at first, it's distilled water. After a while, it's slightly pink. After 1 hour, everything is pink. Okay? So use kinetic particle theory. Kinetic particle theory is what I told you just now. Lah. The particles are randomly moving. The particles collide with each other. So this is a 4-mark question. So that's why they put here any 4. Okay? In a solid salt, the particles can't move. The salt dissolves because the forces of attraction are overcome. Okay? Diffusion occurs. Salt particles move randomly, and then they are constantly colliding and they mix together. So 1 in IG, every line is 1 mark. Not every line, right? Every line in the answer scheme is 1 mark. So you write any 4 lines, you get 4 marks. Okay? Can you understand? So this is not very, very hard. It's just you have to answer accordingly. Your English doesn't have to be good. Don't write long sentences because nobody wants to read. Go straight to the point. Cannot write point form, but write straight to the point. In solid, particles not moving. Particles in fixed position. Full stop. The salt dissolves. Full stop. The salt particles diffuse in the water. Full stop. Like that. Okay, don't use therefore and then no, because you're going to confuse yourself. Can I understand? Can? Okay. Now, this one later lah. This one go home and do, okay? Can? Do this as homework. Okay, finish this as homework. Or later, if you have extra time, you will do. Okay, now, I'm going to go to the next one. Okay, each person take one. Okay. So, okay. Enough or not? Not enough. Okay. Oh, that means I need one more for Jia Yi and one more for Ariel. So Jia Yi doesn't have much fuss.
Yeah.
Oh, you are Ariel. Oh, sorry. Wait, so I have 6 people, not 7 in this class. Okay. You are Ariel. Jia Yi is not here. Xuan Yi also not here. Oh, Xuan Yi is the one not here. Why is he not here? Does he also do orchestra or band? No. Okay. Also, I have 7, so I need to ask Mr. Kong to print one more later. Okay. Alright, second paper. No. Okay, this one is the same as previous. This one, first question, no need to do, okay? No need to do. We will talk about it later. Okay, let's focus on this second page. Okay. Now, definition, when the question asks you definition, you cannot write what you feel. It's not about your feelings. Okay? Definition is specifically what it means. So, when the question asks you what's an element, there are 5 elements, water, air, that's not elements. Okay, you cannot write elements like that. Then you cannot say elements is pure. No, that's also not what elements is. Elements is a substance that is made out of, contain the same number of protons. That means, for example, if I have a piece of carbon, every single thing is carbon, and every single one has 6 protons. That's called an element. Okay, so only one type of atom that all have the same proton number and they cannot be split into anything simpler. So if I just write the symbol like that, Kc is an atom, is a element. Potassium, element. But if I write oxygen, I have to write it in O2. It's a molecule, but it's still an element. Can I understand? Can? Okay, so element means only one type. There are 118 elements found in the periodic table. Okay? Now, a compound is when 2 or more elements are chemically joined together. So, for example, carbon dioxide is made from the element carbon and the element oxygen. They join together, they form carbon dioxide. Okay, other examples, calcium carbonate has calcium, carbon, and oxygen. Copper 2 sulfate has copper, sulfur, and oxygen. So, when there's 2 or more joined together, it's called a compound. Okay, a mixture is when it's not chemically bonded together. So, for example, I take water, I add salt, I mix together, there's a mixture. If I want to get salt back, I just evaporate the water. Correct? Okay? Now, in the periodic table, okay, have you seen the periodic table before? Yes? Yes, okay. Now, my youngest student to sit for IG is 6.5 years old. He was 6.5 years old. He's 6.5 years old when he took when he started learning. He was 7 when he took his IGs for chemistry. He got 88. Okay. He took his maths last year, he got 91. And now he's taking his bio. He's 8 years old now. What? Okay. So whatever results you get for your IG, you must get higher than 88. Okay? You must get higher than my 6-year-old. Not my 6-year-old lah. He's a little genius. Later on, I pass you his not he's from Singapore, so I teach him online.
Oh, you teach it online?
Yeah. Sometimes he comes to my house, like when he comes down from Singapore, he comes to my house. Okay. So if you all ever feel that chemistry is hard, please remember a 6-year-old has done it. Okay? Can?
What's stuff?
Sorry, what? No, it means that you can do it. Okay? There's no such thing. You all are highly intelligent. Okay? If you are stupid, I will tell you you're stupid. Okay? So after teaching you for 1 hour, I know that you all can do this. Okay? 14. 1, 2, 3, 4, 5, 7 copies. Then why I left one copy? And then for the notes. In the notes. We have printed 6. But print another. Yeah. Because you all have exactly 2 minutes. 2 minutes. 2 minutes to go pee and come back. If you need to longer time, that means there's something. Okay. So this is the periodic table. I will give you a copy. If I don't give you today, I'll give you next week. All right. So this is a copy of the periodic table. Okay. So it has elements, all the elements that is discovered by man. Okay. So if you notice, every single element is arranged according to the proton number. So it starts from number 1 all the way to number 118. There's nothing missing. Here 118. Okay. So 1 is hydrogen, 2 is helium, 3 is lithium, 4 is beryllium, 5 is boron, 6 is carbon, and so on. So there are no missing elements. Okay. So they are arranged according to the proton number. So if something has a proton number of 5, it is 100% boron. It cannot be anything else. If something has a proton number 7, it has to be nitrogen. It cannot be something else. So that's what it means by this concept here, where an atom, okay, an atom is made from containing the same number of protons. Okay, can? All right. Now, when you were in year 7, your science is called baby science. Very fun one. It's just circle, 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 circle like that. Okay, that is called particle. Right or not? Last time when you were in baby science, you learn like that. Circle, 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 circle is particle. All right. And then after that, now I'm going to teach you that this particle, it can be an atom, or it can be an ion, or it can be a molecule. Okay, so for now, we're going to learn atom. Atom is the simplest form of an element. It cannot be simpler than an atom. An atom has 3 parts. You know, like how the solar system has sun, and then around the sun there's planets. Okay, and then the planets go in orbit like that. Correct? Okay, a nucleus is exactly the same. Sorry, an atom is exactly the same. There is a nucleus in the middle. Inside the nucleus, there is something called a proton and something called a neutron. And then surrounding it in orbit is electrons. There are 3 subatomic particles. The name of the subatomic particles are proton, neutron, electron. Okay, so proton is, the symbol is small p. Okay, symbol you cannot simply write. You cannot write big P. Why not? What's the difference between big P and small p? Small p means proton, big P means power. Small n means neutron, big N means Newton. Small e means electron, big E means energy. So everything, every single symbol in sciences has a meaning. You cannot mix together whatever you want. Okay, can? Every single proton has a relative charge. Why is it called a relative charge and a relative mass? Because we are comparing it to something. Okay, the mass is so tiny that if I actually tell you the mass of a proton, it will be 0.0000000 something. So what happens is we compare something to something. That's relative. So a proton compared to a neutron, the mass is the same. Okay, but a proton neutron compared to an electron is very tiny. Electron is 1/1A40. Teacher, do I have to memorize this number? Yeah, you need to memorize this number. Okay, so it's very tiny, 1/1A40. Now, the proton and neutrons are in the nucleus of an atom. It cannot simply go anywhere. Okay, but the electrons are in the shells orbiting. Okay, every single proton has a charge of +1, a neutron is 0, and the electron is -1. Okay, they have a specific charge. Okay? Okay, so now, in any chemical reaction that we're going to learn, only the electron can react. The proton and neutron cannot simply go anywhere. If the proton or neutron goes somewhere, what is it called? It is called a nuclear explosion because it happens in the nucleus. Okay, so the reason why we have nuclear power, it's not something big, it's actually very small. It's just the atom break apart. When an atom breaks apart, it changes into energy and it changes into a lot of energy. So that's why we have nuclear power. Can you understand? Okay, the concept? All right, now, sorry, what?
Isn't nuclear reactor just very strong like steam power station?
No, using the energy made from the atom breaking apart, that energy is used to heat up water. That water becomes steam, and then the steam starts moving, the turbine. That's the concept. It's not directly into water. No. Okay, can you understand? This is
How do you break that?
you shoot. So some atoms are not very safe, are not very stable. So you shoot an electron, you shoot a neutron or a proton into the nucleus. When you shoot it into the nucleus breaks apart and then forms protons that break another one, and it goes on and on and on.
Also, it's chain reaction.
Yeah, chain reaction. So the concept is E equals mc squared. Einstein. Okay. E is energy, m is the mass. The mass of a proton. Teacher just now said mass of proton and neutron very small. Yes, but c is the speed of light. Yeah, what's the speed of light? Huh? What's the speed of light?
Like 200 something million.
No. Okay. So the speed of light is closer. Okay. 3 times 10 to the power of 8. 3 million. No, 3 times 10 to the power of 8. 3 million times another 100. Okay. So it's 3 times 10 to the power of 8. So even though the mass is very small, it's not, oh, teacher, like that, I 70 kg. You burn me 70 kg, my E equals mc squared. 70 kg times speed of light. No, you burn already, you become ash, become carbon dioxide. This one is the mass completely changes into energy. When a mass 100% changes into energy, it follows this Einstein theory of relativity. This one, you get it? That's why it produces so much energy. So the entire bomb that wiped out Nagasaki and Hiroshima, the bomb, the size of the bomb, the weight of the bomb is only 1 kg. It's only like this only. The size is much only. This heavy. That's it. You just had to contain nuclear power, even if you had nuclear power, doesn't mean it will explode. You had to shoot a proton inside. You have to make a machine to shoot a proton inside, then start a chain reaction. Get it? So That's what happens. Okay, now, okay, here is the, remember definition I told you just now? Definition is not what you feel, definition is what it actually is. So the definition, this one you can memorize later on lah. Nearer to exam, you must memorize, okay? Proton number is the number of protons in the nucleus of an atom. Nucleon number is the total number of protons and neutrons in the nucleus of an atom. So when you look at the periodic table, okay, if you look at the periodic table, you see carbon. Okay, can you see this carbon here? So it's 6 carbon, C, and then 12. C is the symbol. So 6 is the proton number. 12 is what we call the nuclear number. So it's 6 carbon 12. This is from periodic table. Okay, then why here they write terbalik? Why is the proton number down here? And why is the nuclear number terbalik like that? I don't know. I didn't write it. I didn't invent this. They come out like this. I show you. Okay, so this is the nuclear number. This is proton plus neutron. Okay, and this is proton only. Can you understand? Okay. So that means this carbon atom in the nucleus, there are 6 protons. How many neutrons? 6, because you take 12 minus 6. Okay? So 6 neutrons. And how many electrons? 6 electrons. And the electrons surrounded in shells. Okay? 1, 2, 3, 4. Okay? Alright, now. Okay, let's look at this. This is from the periodic table. Okay? Alright. This is the periodic table. Okay, so what happens is, what is the atomic number? 17. What is the mass number? Mass number is same as nuclear number, 35. Okay, how many electrons? Teacher, how I know? If it's something that is neutral, that means they don't show positive or negative, the amount of protons is the same as electrons. Because every single proton is positive 1, every single electron is negative 1, so the total will be neutral. Okay, so how many electrons is 70, same as protons. How many neutrons? How to count? This 35 is proton plus neutron. This is proton. So neutron equals to 35 minus 17. So you get 18. Get it? Get it? And how many protons? 7. Okay, write this down. Okay, can? All right. This one only answer very easy lah. Okay. If you're done, you guys done? Can okay. If an atom, if it's an atom, that means proton number equals to electron number, because proton is positive 1, electron is negative 1. Okay. If something loses electron, it becomes positive because electron is negative now. So if I lose it, I become positive. So if you lose 1 electron, you become positive 1. If you lose 2 electron, you become positive 2. If you lose 3 electron, you become positive 3 lah. Okay. If you gain 1 electron, you become negative 1. If you gain 2 electron, you become negative 2. When you gain or lose an electron, you're no longer called an atom. You are now an ion. Can you understand? Can you see the difference? Yeah? Cannot? What? Sorry? Oh, you say yes. Okay. All right. Make sense? Make sense, huh? Okay, so let's look at this. Okay, sulfur. The element is sulfur, huh? Okay. Sulfur. Okay, let's look at this one. Okay. If it's an atom, they will just write Li. If it's an ion, they will write 2 negative. That means sulfur has gained or lost electron. Gain. Gain how many? 2. But the proton can change? Cannot. So the proton is just 16. Okay? This one, neutron is how? How do we count neutron? 34 minus 16. How much is that?
18.
Okay? Can get it? The electron, because this one is 2 negative, the electron will be 80. Remember? Negative is gain 2 electrons. Remember? Gain 2 electrons. Okay, can you all try do this? All right, so lithium, proton number is 3. Neutron is how much? 4. And then electron is 3 because it's neutral. Okay, this one, how do I know what is 19? So you look at the periodic table. Okay, later on I'll give you one. Okay, so 19 is potassium. Okay, 19 is potassium. So K. All right. 19, you write down here because proton number can never change. Okay, how many is the neutron? 19 plus 22 is 41. Okay, is this guy neutral, positive, or negative?
Sorry. Negative 1.
Positive one. Because you see, it has less, see, less 1 electron. Can see that? This extra. It's supposed to be 19, but now it's
Or not.
get it now? You get it now?
Okay.
Yeah. Okay, get it up. All right. Let's try one more. Okay, you're done here? Okay. Try, not this one. Wait, let me show you. This one. Try do this one. Same concept, same concept. I will show you the periodic table so you can find the elements in the periodic table. Okay? Same concept, Okay, I'll show you the periodic table. Can see? Is it too small? Can see it? Yeah, I'll send it bigger. I'll also send you a copy. Ah. So this question, this question, the one here on page. Oh, sorry, got no page number. You know which one? Okay. Right now, this is the periodic table. Okay, I want to go to the mushroom.
Stage level that times. Never know. Yeah, since it was such a thing, I was supposed to be enough. I assume you understand. Yes. That, but I did. They find patients. I forgot the graph what I make by the first make like. If I see on the I don't know what's so small. I don't know how dense that is. It's bad. Shouldn't understand. It's bad. It's not about it's not it's not it's not about it's slightly different about just due to the fact that it's if that's the reason. I mean it's wow. Yeah, this is bad, right? Not really. Just you can't do math with it. I try to calculate it. You can count. Can't do math with 160. Oh, but it's not so all it's 70 maths. Plus is not always there. Plus three is not. No, I left my one excuse from it. Very good. No, I don't know. Là như là nó biết nó sẽ chỉ là cái sản này. Nó cái sự không chịu được. I mean, I don't know. He was responsible like solve this study with no, it's the one who say like some I'm supposed to understand, but there's a big problem in college. Okay, it's good.
Small, is it?
Yeah, sure. That's good.
Hello, Peggy in my class.
Okay.
Read the back.
Okay.
No, Ariel. Too small. I send it to your group chat. Test.
This guy. Yeah.
Play game. What are you all? You're like year 10, huh? Year 10, okay. Okay, done?
It's
Okay, so what you do is, okay, the biggest problem that students always make, the biggest mistake that they always make is they don't open their eyes big enough and then they don't see that sometimes they switch this. Okay, so this one is proton. So who is K lah? K. Okay, 19. See? So the one on top you take 19 plus 20 is 39. Okay, does it have the same number of electrons as protons? Yes, so it's neutral. Okay. All right. This one is 26, 26, 30. All right. Oh. Oh. Next time you must just read it carefully. Actually, questions are not very hard. Just to read carefully. Okay. This sure. Proton is 3. Okay, so 3 is lithium. Okay, lithium. So Li, and then down here, right? 3, and then up here, right? 3 plus 4 is 7. Okay, now this one is 2. So it gained or lost electron? Lost. So it's positive 1. So just write positive. Okay, can? Okay, gallium 31. Now this one is 3 positive. So it has lost 3 electron. So it is 28. And then 39. Is it? Can? Okay. And then this one, 30, who is 34? So look, 34. SE selenium. Okay, it's 34. And then here is 34 and 79. You add these two together, 79. Is it neutral? No, this one has gain gain 2 electrons, so it's 2 negative. Hi. No, it's okay. I don't know why couldn't on. There's something else to on, is it? After don't know how long only to on the thing. Is there a reason? Am I supposed to press anything or just the
I think it's supposed to be on when you actually.
oh
But maybe there's a timer then.
on the timer lah? Oh,
Okay.
because I press the so next time if it doesn't work, what do I do? I just use the remote, right?
See, get from the only one access to the timer.
Oh, okay. All right. Thanks, bye bye. Okay, can? Okay, so now sometimes the particle has different number of protons and neutrons. Same number of protons but different number of neutrons. These are called isotopes. Okay, again, definition. So for example, if I have carbon 12,6, carbon 13,6, and carbon 14,6. Okay, now let's look at this. This one has 6 protons, 6 electrons, 6 neutron, right? This one has 6 protons, 6 electron, but 7 neutron. This one has 6 protons, 6 electron, but 8 neutron. So because they all have 6 as their proton number, I need to get me a new.
What's up, I
Yeah, I don't know. It likes to do that. Huh? Then next time if I remember, I just liquid paper lah. Okay. So it has same number of proton. As long as the proton number is the same, it is the same element. Okay. But the neutron is slightly different. Okay. So the normal carbon in the whole world, 99.99% is all carbon 12. Okay. About less than 1% is carbon 13, about less than 1% is carbon 14. Okay. Now, for the first one, 6 proton, 6 neutron is in the atom, right? The electron same only, right? The third one, 6 proton and 8 neutron in the nucleus, right? So 6 and 6 is balanced like a seesaw, but 6 and 8 is like not balanced. So what happens is, because it's not balanced, it's not happy. And when it's not happy, they say, I don't want to be friends with you. I go out. And I just told you, if something happens to the nucleus, it becomes a nuclear reaction. So this actually happens every day. But this is so tiny that we don't feel it. We are made from carbon, right? And all of us have this. All of us have this little bit of radioactive carbon in our bodies. The carbon 14. Remember I told you less than 1%? Every single living organism, from a bacteria to an elephant to a tree to a dinosaur, all have this carbon 14 in our body. So this is radioactive carbon. Okay, it doesn't mean that, hey, I'm Spider-Man, I'm radioactive. No, it means that you release a little bit of radioactivity. As long as you eat and you are alive, you have this. But when you die, do you still have it? It becomes more or less. Less. Okay, the older you are as a fossil, the lesser of this. So that's how they know how old a dinosaur is. That's how they know the paper is 1,000 years old or 100 years old. Get it? So it's called carbon dating. They see how many radioactive carbon is left inside the carbon dating, yeah. Okay, so it's to know how old the fossil is. Can I understand? Those of you in Form 4, oh no, we are in Form 3, so you won't know. All right, so what is the definition of isotope? Finishing it. Isotope is different atoms but the same element. Same number of protons but different number of neutrons. This is the definition. Okay, so they have the same chemical properties because they have the same number of electrons and same electron arrangement, but they have different physical properties. Okay, so let's look at this. Is these two isotopes? Okay, can you fill in this? Are these two isotopes? Are they two isotopes? Yeah, because they have the same proton number, 31, 31. The electron also same, 31, 31. But the neutron? You do not count. This one is 40. Yeah. Okay. Can you understand? All right, we will stop here.